Right, so we know that the slope of the line, I'm just going to have to cope with this slowness, also called gradient. Oh, this is all. Also called gradient is found by doing or knowing the change in y divided by the change in x. All right? Yes. So we've got to change it. And we have also seen different symbols for that. So I've said change in y divided by change in x, and that's a delta sign. Now you'll also see this as you go further on in your maths. So just to introduce you, so it doesn't look weird before, this sign here can also be written as lowercase. It's not a d, although people do say dy dx. It's actually a delta. It's just
Looks like a hole.
it's a lower, guys. A comment, fine. When you start turning that comment into a whole discussion, that becomes an issue. So it's delta y divided by delta x, uppercase, lowercase, Greek letter, right? So it just means the gradient, the change in y divided by the change in. We also looked at it when we said the change in y can be expressed as a formula, didn't we? y2 subtract y1 divided by x2 subtract x1. So that's the difference in the two coordinates. All right? It's very difficult. My computer's getting slow. There's a difference in the two coordinates, so that would be the gradient. Now we do have a letter to represent gradient, and I will use the letter M. And you'll see why. Sometimes it's A, but there's one that was commonly used for M, right? And you may have heard y equals mx plus c for a straight line, but we're going to be looking at that. So this is what we're talking about. So we're looking for how do we work out the slope or the gradient of a line, but we need to remember what that actually means, and that means how much something is changing. So if I were to graph the amount of water in a big tank, and that is going up by a certain amount every minute, I would get a straight line. And the gradient of that line would be the amount of water being added every minute, yeah? Make sense? Yeah? If that amount changes constantly, I will have a straight line. If that amount changes, I will not have a straight line. So would there be any reason why the amount of water in a big tank would go up not in a constant manner? Well, if it's raining constantly, let's just say we simplify it so it rains, the same amount of water is coming all the time, the water would raise up. But depending on one thing, I want you to think about opening a tap and filling up your water bottle.
If it gets narrower.
Notice if it's sideways, it will still.
If it gets narrower.
If it gets narrower, what happens when you're filling up your water bottle?
And all of a sudden it's going to really go.
Suddenly goes and straight to the top, because at the top of your bottle it gets narrower and the water level will come up faster. Okay? So what we're saying when it's a constant is when the bottle shape would just be a long, tall, thin cylinder. That would give you a constant change, a constant rise. As long as, like my should have said, if it rains and then the rain calms down a little bit, it would slow. So lots of things can change it, but we are looking at situations where it's constant change. So what we want to know is, just to check, can we identify this in a line? So draw yourself a set of axes, right, like we've just been doing. And we'll draw some lines. So I would like you to draw a line with a gradient of +3 for me. +3. So I want to know when m equals 3, I would like to know what would that line look like. Anyone struggling? Anyone not know? No idea? You know. You don't know because you weren't here for all of it. Would anyone like to share their method? No? So what I'm hoping you do, the line, the specifics of the line, all we're looking at is the gradient. So I'm actually going to pick a point down here, 1 point. Sorry, trouble with computers. 1 point there. And if I go across 1 square, how far up do I need to go?
3.
3. So I would put my next dot there. If I went across 2 squares, how many squares would I have to go up?
6.
6. Does that make sense? So for every 1 in x, I have to go up 3, because 3 divided by 1 is
3.
3. If I went across 2 squares, I would have to go up 6 squares. And you'll notice that I went 1, 3, or 2, 6. Well, that's like doing 1, 3, 1, 3. Okay? So my line will go through those points. Okay? Now, just to show you the whole triangle thing again, if I go the change in, come on, change in x, I'll have to do it. Change in x, change in y, what do you notice? 1, 3, there's my right angle triangle, that's what we were doing before. Now your line could be anywhere on there, so I could have actually drawn a line going through the centre. Yeah?
That's what I did.
I could have drawn a line going over here. Could have gone all the way over this point here. Could have had a line over here.
Never had one anywhere.
Could have had a line anywhere as long as the gradient. What do you notice about all of those lines?
They all have a gradient of 3.
They all have a gradient of 3.
And
They're
they're
all
all
going in the same
going
direction. And what do you call lines like this?
Parallel.
They're parallel. So that's what we've got to talk about. Parallel lines have the same gradient.
Status.
Right. Could you now draw for me then a line with a gradient of -1/4?
That's easy.
I would like you to draw me a line that has a gradient of -1/4. Have a go. Focus on your own work. Don't get silly and giggly and say, I can't do it. Don't do something, scribble out, go I'm wrong before you've had it checked. Have a go. Just remember, what is a fraction is a division. Yeah? A fraction is a division, no? 1/4 is 1 divided by 4. A gradient is a fraction that might... So we've got already the change in y divided by the change in x, but it's expressed as a fraction still. Oh, I'm waiting. Right, so we want to do a gradient of a quarter. Those of you that did manage to give it a go, great. Those of you that didn't feel you could even know where to start, you need to follow this through then. Okay, so when gradient is easy to do, like this one over here, right? When the gradient is 3, what does that mean? It means that the change in y is 3 and the change in x is 1. So we have 3 divided by 1. It could also be 6 divided by 2. 12 divided by 4. Okay? Got that? So if I put my points further apart, it would be 12 and 4. Got that? Now, it just so happens that that fraction simplifies nicely to 3. Now, if we look at this one that you're like, oh my God, I have no idea how to do this. But actually, it's just a fraction that doesn't simplify to a whole number. So actually, the change in y is -1. The change in x is 4. So, pick a point, right? What's the change in y?
It'd be -1/4.
Negative.
No.
Say what first came to your head. Negative 1. That's what you were going to say.
Yeah.
Stick with it. Right. The change in y is -1. Now that means it goes which direction? Down. So from this first point, right, the change in y is -1. So I go down 1 instead of going up 1. Then my change in y is 4. So I go across and I do my triangle and I go all the way across to 4 and I put my next dot. Now, that's where my line goes. There's my line.
It goes down by 4.
So it goes down by 1 and across. Now my tip is that the x change should always be positive. The negative is applied to the change in y. So you either go up or down in y. If it's a positive gradient, you go up in y. If it's a negative gradient, you go down in y. Okay? Now, on the same set of axes as I've just done this one, I would like you to do a gradient of 4. Please. So a different line, but on the same set of axes as you just did that one, I want you to do a gradient of 4. 4. So what's the change in y?
3.
4. And what would the change in x be? 1. Or the change in y could be 8 and the change in x could be 2.
Now I'm already done. I know, guys.
Getting it?
I have several wall runners.
So, guys, remember I'm recording. So the change, right, guys, just to remind you, it's not y is, it's the change in y is 4, and the change in x is 1. So I can put a point anywhere I like, doesn't matter where it is, and then I go across. So you can either do the x or y first. Do we do the y first or the x? Let's do the y. So the y needs to go up 4. 1, 2, 3, 4. And then we go across 1. So actually I've already got a point there. Okay. And I'm going to go from that point through that point. I could put it here if I like. I could start here, go across 1 and up 4. Across 1, up 4. Okay? It can go anywhere because I've only asked you for a gradient of 4. Now, extra credit for anyone that can tell me the relationship between a line that's got a gradient of -1/4 and a line that's got a gradient of 4.
It's just turned 90 degrees.
What's that called?
Perpendicular.
They're perpendicular, yes.
Do I get anything for that?
Extra credit.
I know.
These two lines are perpendicular. That's something we are also going to look at next time. We're going to be looking at parallel and perpendicular lines. Okay? Right. Something else we want to talk about. There is another name for this that you will hear mentioned over and over and over again. So I'm just going to recap. So in your notes, you're going to add this, even if you feel you've already written it. So we have gradient. Okay? Gradient is calculated by doing one y coordinates, subtract the other one, divided by the difference in the x coordinates. That can be represented by writing the change in y divided by the change in x. Now this is also very regularly referred to as rise over run. Why do you think it's referred to as that? Yeah?
Because rise is the y-axis because it goes high.
Yeah.
And run is the x-axis because it goes long.
Yes.
So they can talk about
Pardon?
yeah.
Whatever you like. But climb over, crawl, not fall. Good. I thought you said fall. But yes, another one. It's the same with coordinates, kind of, isn't it? But I would say, you know, pigs fly. No, pigs don't fly, they walk. Rise, run. Yeah. But what's important is you get the idea of the how much I go up by gets divided by how far I go across. And this is also known as the rate of change of whatever we're talking about. Okay? So in this case, if I've just got x's and y's, it's called the rate of change of y with respect to x. And as the rate of change of y increases, what happens to the gradient? Nope. It increases. And what happens to the line? It goes up more, thank you. It gets steeper. So, if I said to you, I'm going to draw two lines now, and I'm going to say that these lines are to do with the y-axis is the height of water, okay? And this axis here, the x-axis, is not an x-axis, it's a time axis.
What's the difference? What?
Well, x is what we call it when we have no label for it. Y is what we call it when we have no... So if I call it height of water, I could say it's y, but I could also call it h. And instead of time, I could call it t. It's not always x and y. So if I draw a line like this, okay, so I'm going to draw my line, looks like that, and then I'm going to draw a line that looks like this. Right, so don't draw it yet. I just want you to look at the screen. All right. This represents two taps. This is tap A, this is tap B, and they have been turned on. Right? So there is water coming out of the taps, and they're two separate taps with two separate containers. So imagine they're like a regular shaped rectangular tank underneath your house or your apartment. They're filling up the water in your thing, right? What can you say about the difference between tap A and tap B, and using good vocabulary for me? Okay, go for it.
The difference between tap A and tap B will be B subtracted from A.
No.
The difference-
I've got two different lines here.
What would be, what
So I'm not asking you to work out the gradient of two separate lines. I'm asking you what's the difference in the situation. Remember the words I've used and are still on the board. What would you say?
A has
All right, so A's line has a higher gradient. The gradient is a higher number. And what does that mean?
That the water fills up at a faster rate.
Good, I like it. The water is rising at a faster rate, yeah? You got that? So the rate of change of height of water is faster for A than B. Because A has been turned on more, maybe. Or it's a bigger tap, or there's a bigger pipe, right? You know. Could I ask you, which one has the higher gradient? A. Okay. What is the gradient? Can you tell me?
B.
The gradient of A is 1, the gradient of B is 2, and
No.
It's not exact.
It should be exact. It's right. So let me just tell you, this line does go through every single one. This one goes across 3 and up 1. Across 3, up 1. I know it's not brilliant, but that's rubbish actually. Now I've seen it. But the final thing I want to mention, you need to stop that, otherwise we come back after school and we talk about. Okay. The fact is, you can't tell me the gradient yet, because what's missing?
The points. Well, I mean like the bottom.
Information.
Information, the information being, as Mackay was trying to say, the numbers. So let me tell you this. Every 2 squares is 10 seconds. All right? Every 1 square here is 1 centimetre. What is the gradient of line A?
1 centimeter.
2.
Like you were
What is the gradient of line A?
1.5. Wait, what did you say?
What is the gradient?
Don't forget everything you've done. What's the change in Y?
1.
1. What's the change in X?
10.
5.
Oh, it's 5, it's definitely.
So
I was thinking.
that leads me to the guys. That leads me to the final thing I'm going to say, and we'll talk about much more next lesson. Is do not, although we have been doing to this day, do not simply count squares. You must look at the numbers on the axis, the scale. Okay. Have a good weekend.